You've seen it 100 times, a bee trapped against a window pane, bumping the glass again and again and again, and you probably thought what most of us think, that there's nothing really in there, just a tiny machine of wings and instinct running the only program it was ever given, a body with no one home inside it. But a few years ago, in a quiet lab in London, a group of bees did something no one had programmed. No one had trained them for it. No one rewarded them. They played. Play is a strange thing to find in an insect. We expect it in a puppy chasing its own tail, in a kitten ambushing a ball of string, in a child who won't put down a toy at bedtime. Play feels like a luxury, something only the soft, warm, clever animals get to do. So what does it mean when the creature doing it has a brain smaller than a grain of rice? To understand that, you have to go back to a lab and a small accident that nobody meant to make. At Queen Mary University of London, a scientist named Lars Chittka had spent years studying how bees think. And bees, it turns out, think about a lot. In 2017, his team taught bumblebees a clever little trick. Roll a small wooden ball to a marked spot and you earn a drop of sugar water. The bees learned it quickly. They were good at it. But then someone noticed something strange. Even after the sugar reward was taken away, some of the bees kept rolling the balls. For nothing at all. It could have meant nothing. A glitch, a leftover habit. But a graduate student named Galpayage couldn't let it go. She wanted to know for certain, so she designed an experiment built around a single, almost absurd question. Do bumblebees play? Not work, not forage, play? Here is what she did. She placed 45 bumblebees in an arena. On one side, food, all the sugar water and pollen they could ever want, freely given. Between the bees and that food, a clear and open path. They never had to earn a thing, but along the edges of that path, she scattered small wooden balls. Some were glued down, some rolled freely. And here's the key. The bees did not have to touch a single one of them. They touched them anyway. Again and again, the bees stepped off the easy path. They walked over to the loose balls. They climbed on top, and they rolled. A bee would wrap all 6 legs around a ball, almost like a hug, then scoot backward and push it across the floor, then turn around and do it again, and again, and again. Some bees rolled a ball only once or twice and moved on, but others couldn't seem to stop. One bee, over the length of the study, rolled the balls 117 times. Picture that, 117 trips off the path, away from an easy meal, just to push a ball around a floor. There was no sugar waiting at the end, no mate to impress, no nest to build, no larvae to feed, nothing an insect is ever supposed to care about. Just the rolling itself, just the doing of it. The kind of pointless, absorbing repetition you'd recognize in any child who's found a good toy. But scientists are careful people, and rolling a ball is not automatically play, so the team held the behavior up against the strict criteria researchers use to define real play in any animal at all. It can't serve an obvious purpose. Not food, not shelter, not mating. It has to be voluntary, done by choice. It has to be repeated, not a one-time accident. And it has to happen when the animal is calm and safe, never when it's stressed, hungry, or afraid. The bees rolling checked every single box. Then came the detail that's genuinely hard to shake off. To be sure the bees actually enjoyed the rolling, Galpayage ran a second test. She sent bees through a colored room to reach their food. One color always had the balls. The other color never did. Later, she offered the bees a simple choice between the 2 rooms, this time with no balls in either, and the bees moved toward the color where the fun had once been. They remembered where the good time was, and they went back looking for it. When the team looked closely at which bees played the most, a very familiar pattern rose up out of the data. The youngest bees rolled the most balls. The older ones did it less. It's the same shape we see in puppies, in kittens, in children. The young ones play the hardest, before the weight of the world settles in. That same curve. In a creature you could balance on the tip of your finger. And once you accept that a bee can play, a much harder question opens up beneath your feet, because play is never just an action. Play is a signal. It points to something underneath, a feeling, enjoyment, pleasure. And if a bee can feel pleasure, then what else is in there? What else can it feel? As it happens, scientists have been quietly answering that question too, in a whole separate line of research. In one study, bees were given a gentle but firm shake, meant to mimic the jolt of a predator's attack, and afterward, those bees turned into pessimists. Offered an ambiguous smell that might or might not lead to reward, they expected the worst, and they held back. It's the same thing a person does after a bad morning, reading the ambiguous moment as a threat instead of a chance, and inside their tiny bodies, the chemistry had shifted to match. Lower dopamine, lower serotonin, the very same chemicals that rise and fall with your own bad moods. And the reverse holds too. Give a bee a small, unexpected treat, and it turns optimistic. It makes bolder, brighter choices, as though the whole world had just become a slightly friendlier place. And when researchers blocked its dopamine, the chemistry of reward, that bright mood simply disappeared. The same molecule, the same story your own brain tells, running quietly inside something you might have swatted this morning without a second thought. So sit with that picture for a moment. A pessimistic bee, bracing for bad news. An optimistic bee, reaching for the world. A bee that plays when no one is watching and nothing is owed, for no reason at all except that it feels good. These are not the words we were handed for insects, but they are the words the evidence keeps pressing into our hands. None of this means a bee feels the world the way you do. Whatever its joy is, it must be stranger, smaller, and far more alien than anything you'd recognize. A flicker, not a flame, but a flicker is still light. Strange and small is not the same thing as nothing. And nothing was the story we told ourselves for a very long time. The comfortable story, the one that let us stop looking and stop caring. It's an easy story to keep believing, right up until the moment a bee wanders off its path, wraps 6 legs around a wooden ball, and rolls it, for no reason in the world but that it wants to. So the next time you find a bee at your window, worn out against the glass, pause before you reach for it. What you're looking at is not an empty machine. It's a small life that can have a bad day, that can, in some quiet way of its own, have a good one. That might, given a slow afternoon and a little ball, simply choose to play. And once you've seen that, it's hard to unsee. It changes the whole small world you've been sharing all along. We will never fully climb inside a mind that tiny, but maybe we can stop pretending it's empty. If this made you look at the smallest creatures a little differently, stay with us. There are stranger minds all around you, closer than you think, still waiting to be understood.